All right, let's get into the mole. What is it? All of that. So the mole is really, really important for understanding chemistry. So it's considered a counting unit, and it provides the measure of the amount of the number of atoms that are in that sample. So if I have just a pile of some sort of chemical, how many atoms are there? And we use the word mole the same way that we might say a dozen or pair to represent 12 and 2. So I know that if I have, 1 dozen cookies, that means that I have 12 cookies. It's the same number of cookies, it's just expressed in a different way. Or if I have, 1 pair of socks, that actually means I have 2 individual socks, not that I just have 1 sock together. So here we see that 1 mole of an element or compound contains 6.02 times 10 to the 23 particles. And particles is just a sciencey word for things. We can use it to mean different things, but it makes us sound smarter to say particles instead of things. So of course we're going to use that. And if there's 1 mole of NH3, that means that there are 6.02 times 10 to the 23 molecules of NH3 or ammonia. And the mole is often represented as a coefficient in front of the substance. So we see that in balanced chemical equations like in first semester. So for example, if I just see NH3, I know that that means that I just have 1 mole of ammonia, because we know chemists are kind of lazy. We don't write the 1 in front. Whereas if I have a 10 NH3 right here, oops, sorry, I'm trying not to write on the actual number. There we go. 10 NH3, that means I have 10 moles of ammonia. And so what I want you to do is I want you to pause the video and I want you to go ahead and answer these questions, okay, based on your reading, and then press play when you're ready to go over the answers. Okay, so a mole. A mole is a counting unit. It's a counting unit to measure atoms. Okay, and we use it because it's a lot easier to use numbers like 1, 2, 3 than 6.02 times 10 to the 23, right? Large numbers, which, by the way, when we talk about 6.02 times 10 to the 23, just remember that a positive 23 means you move this decimal place over to the right 23 times. So that's 602. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, that's 602 with 21 zeros after it. So this is an extremely large number, and I don't know about you, but I don't like doing math with that number, which is why I'd rather say, okay, all of this is 1 mole, because I'd rather do math with the number 1 than I would with that, okay? That's why we do it. And so a mole is equal to 6.02 times 10 to the 23 particles. So if I have 1 mole of basketballs, it means I have 6.02 times 10 to the 23 basketballs. It could be whatever it is we are looking at. And here it says how many moles of oxygen are present in the equation. Well, we see that oxygen is right here, and since I have a 7 in front of my oxygen as a coefficient, that means I have 7 moles of O2, which, remember, fun fact, since oxygen is by itself and it's diatomic, that's why it has the 2 there. And so let's get into this 6.02 times 10 to the 23 situation. So this number, okay, the amount of particles, is referred to as Avogadro's number. It's based off of, that's Amadeo Avogadro. He's the Italian scientist who was able to figure this out. And he basically took exactly 12.000 grams of carbon-12 and was able to do some math to figure out that 1 mole of carbon had this many atoms of carbon. And so everything is based around that. And so when we know the amount of particles, it allows us to understand how different chemicals behave, predict the outcomes, things like that. And Avogadro's number is going to have different units that can be substituted for particles. Remember, particles just means science or like things. So sometimes for single elements, we talk about atoms, but for covalent compounds, we'll use the word molecules, or for ionic compounds, we'll use the word formula units. So remember, if we're talking about, for example, I might say 4 atoms of silver, right, which is a single element. There's only one capital letter, so I use the word atoms. But if I'm talking about a covalent compound like carbon dioxide, and we know it's covalent because it has only nonmetals, then I might say 4 molecules of carbon dioxide. But if I was talking about something like calcium oxide, which has a metal and a nonmetal, then I would say that I had 4 formula units of calcium oxide. So these different different words represent the structures of the single element, the covalent compound, and the ionic compound, and we use them with Avogadro's number, okay? And it provides us a standard way of comparing them. So when we're using Avogadro's number, we can also use other measurements, such as mass, which remember mass has the unit grams, or volume, which we use milliliters. You should be familiar with that from density, okay, to determine the amount of particles a sample has. So we can go back and forth between grams and volume and moles and particles, because you can't actually count how many atoms there are in a lab. So as we review, what is Avogadro's number? Avogadro's number is 6.02 times 10 to the 23 particles, and that number is on the back of your periodic table. The county finally added it there as part of your formula sheet, so you do not have to memorize it, but you probably will on accident anyway. When we talk about ionic compounds, instead of using the word particles, we're going to use the word formula units. And instead of particles for covalent compounds, we'll use the word molecules. And when we talk about single elements, we'll use the word atoms. So this is kind of our introduction to what the mole is, what is Avogadro's number, because these are going to be critical for our understanding this semester.